So why I'm introducing myself as MJ is because I have a very hard name to pronounce and surname is even worse. So I even don't want to mention it. So if you have a direct question, you can just ask me, hey MJ, I have a question. Can you answer it? And then I will try to do that. And I welcome you to today's presentation. We will talk about handshakes, but handshakes in the area of tightly and loosely coupled systems. This is something that will probably save your ass in the future, in the projects that you will be working in. This is something that we are struggling with in every single project. And here, very important thing is that all that you will see today in the presentation, of course, is open sourced, my drawings as well. And it's extremely based on the practical experience of myself and my colleagues from all the teams that I worked in my projects. And about me, who am I? I'm mainly a problem solver. I really don't like all these titles like enterprise software architect or whatever else, tech leads, super hyper director of software programming or whatever else. Blah. I hate it. So I am just a programmer. I moved here into Switzerland in March this year. And previously I lived here in 2017 for around 10 months. Can any one of you tell me what is this? No volunteers. A nice spaghetti with tomatoes, yes. In general, about pasta, there are two legends. One legend is that pasta came out during some storm. There was a flower on a ship. And during the storm, water from the sea came into the pots of the flour, and then pasta came out. And sailors started eating pasta. Another legend is that there was a baker who was doing the bread dough, and this bread dough, which he had on his fingers, he was putting after his work into his soup, and then he was full of it. However, these are legends. And spaghetti, which you can see here on this image, this is something that probably came from China. So 4,000 years before Christ, it came out, and then it was brought by the Arabs to Europe, to Italy, and popularized by Italian. And it was so much popularized that we as IT guys overtook a saying, spaghetti code. What is a spaghetti code? Spaghetti code is exactly the thing which you can see here. So everything is tightened with everything. So we have these handshakes between every single element inside the code. Another saying for this spaghetti thing is tight coupling. And within this tight coupling, you can imagine friends. And the friend on the right side is having a birthday. Another friend is giving him this gift. And of course, after receiving this gift, I am doing a handshake. And it's done. But this is like a tight coupling. I need to see my colleague. I need to give him this birthday gift. Usually, I need to give him a handshake. You know, this COVID times, yeah? It's quite hard sometimes to do that. So what do you think? What would be possible to give to my friend this birthday gift in the other way? Any ideas? No idea? Okay. Imagine loose coupling. And here we have friend A who is putting this gift to some kind of a post box. Do you know such post boxes around where you can, let's say, order something from Amazon and then you have it at your place, at your city, and you can take it out. So this is first friend who is giving it. And then afterwards, second friend who is having this birthday, he receives a message. Hey, your gift is inside the post box. So after receiving it, he goes into the post box and gets it out. And this is exactly loose coupling. So there is no direct communication between involved parties. And this is exactly how it can be achieved as well in software. We do not need to call directly any modules, services, or whatever else. We can do a loose coupling. What is our case? Our case is a big company which started with event organizing application. They had a great success in the market, so everything what they delivered was loved by the users. But after some time, users started complaining, hey, the software is slow, there are bugs. After 3 releases, the maintenance costs were already higher than the profits. And that's bad, because probably you need to close the company. And from the perspective of the architecture of our solution, we have a system that is a big monolith. Monolith means everything is deployed as a single unit, and projects, let's say, are stored under the solution itself. And the architecture of this solution from the perspective of the layers, we have the N layer one, so we have a presentation layer, then the business logic, and then some kind of a data access. In general, there are some modules like events. We have some module for generation of the invoices, for ordering the tickets, for creation of the tickets, and many, many, many more. From the API perspective, you know what is the API? So you can create a client, and then on this API level, you see some kind of functions, methods that you can call, and you can see a lot. So you can register the user, log in the user, delete the event, create the event, buy ticket, return it, whatever. Many, many, many more cases. And from the analysis perspective, we have here first problem. This first problem is inside one module, so the same module. You saw on this picture before, we have module events, module complaints, tickets, orders, invoices. So let's say we have events module, and here we can have a lot of different problems. One of the biggest is that we have a controller. You know all what is controller? Plus, minus? Okay, this controller has some dependencies, and it depends on the event service, on the event type service, on a member service, member, login, register, type, just create an event type, maybe it's a concert, maybe it's a football match or whatever else, and even location, where you are creating the locations, you are selecting the locations, and all the things around. As lovers of dependency inversion and dependency injection, we started to do a lot of interfaces. So instead of having dependency on a concrete implementation, like this event type service or event location service, we said, okay, let's do the interfaces and hide the implementation behind the abstraction. Therefore, you can use dependency injection, which you can see here through the constructor. This is a .NET code, so I'm not sure if you are aware of that, but in general, concept is the same between object-oriented languages. And therefore, we have here great assignments, all is fine because it's hidden between the abstraction. But is it? Unfortunately not. It's not, because you are still dependent on abstraction. Concrete one. Your controller knows that there is something like iEvent service. It knows that there is something like iEvent location service or iEvent member service, yeah? Not good, not good. So first solution which you can handle here is to split the controller. And for the splitting of a controller, from now we have the event controller and event location controller. From that perspective, in event controller we have something to create the event, and to get the event from event location service, similar one. So of course this is a very basic presentation, that's why it's quite similar. And as you can see, the event controller has just dependency to iEvent service abstraction and location one to iEvent location service. It's already better, but the question is it the best what you can get from that solution? Yes and no. Why? Because there is another one which you can use inside your architecture, a very basic concept of CQRS. Does any of you know what is CQRS? This is an acronym for Command Query Responsibility Segregation. And it looks that way, that me as a user, so I am this red dot, I make a request on a UI. So you can imagine a web page, and I click on the login button on a login form. Then my request goes through command, and this command says login this user, because I command you to do something. So, hey, I want to log in, or I want to register. I want to change the state of the system. Logged in, yes, no. So this is like a comment that you perform on your application. Then it goes to some kind of a handler, and this handler handles just this tiny comment for login. This saves you in the area of single responsibility principle from the solid rules. And this handler writes the state into the database, which is for write operations only. So modifying the state of an art. In the meantime, the write database is synchronizing with the read database, and that's it. Now, my user wants to see all the events that are available inside the system. So what does he do? Again, he clicks somewhere inside the application, the request comes, but now I am not commanding because I am not changing the state. I am just showing the events which are stored in the system. What I do? I go with query. I have another handler which serves this query for getting all the events, and I am reading it from the read database. So now everything here is splitted. Write operations and read operations are having completely different flows. How can we do that from the perspective of the code? What I have here is again our event controller that you saw before and event location controller. However, none of them are anymore based on the services that you saw before. So before you had here iEvent service and here iEvent location service. Instead, there is something which is a mediator object. And this mediator object is allowing one and the other component of your system to communicate indirectly. So here it looks like that whenever my user says, hey, show me the event because I want to get it. So I call API, and in this API I have the event controller connected with the get method, And to mediator, I am sending the information that I want to get an event. And you can see here, get event query, which I created. And therefore, in the get event query, we will have this, for example, event service injected. Event service, of course, because we are based on the abstraction level. Same here. Here, for the creation, we are sending the command. So I want to create something. I want to change the state of an art of your database. And now I have a handler which has, again, injected the abstraction event service inside itself. And now my controllers know nothing about specific implementations, how things are handled. So we are keeping them as thin as possible. You see, it's just a one-liner, and that's it. And you can ask, okay, but what about production systems? Exactly the same. In production, your code can look exactly the same. There might be only one line in the controller. So this is another solution of the problem that is raised inside one module. From the perspective of the problem between different modules, we are coming to more complex knowledge. Imagine that our services, our modules in monolith, so events, complaints, tickets, orders, invoices, they are like spaghetti. They are referencing each other. So like complaints is referencing events, orders, invoices, orders are referencing events. Now imagine you change something in events. And complaints, tickets, orders, and invoices will be probably affected by this change. So, you as a programmer, you have to solve one bug, just one bug. In orders, you solved it, and there are 200 bugs. Because they are all tightly coupled and all depend on each other. Now question. You can go to Menti. I don't know if you know this application, but you can scan QR code and just write what could have gone wrong in such architecture where everything is coupled with everything. Is there anyone scanning it still? Just raise your hand. If not, then I will open it. Design evolved over time. No mediator between. Yes. And other ideas? So, exactly. Design evolved over time. This is a very important thing because usually at the beginning of the project, it's like, hey, we can just do something. Let's look at it, how it will work in the market. You know, there is something which is called lean startup. Just do the minimum viable product and check the market. And it's great way to check your product. But it's quite often that this product that you said, okay, let's develop it in 1 month or 2 months, it will not be re-implemented. It will be just new feature added over new feature and over new feature and over new feature. So this means that there is a high chance that your system will have this tight coupling since the beginning, and if there will be no decision, just let's re-implement the things which we did in this 1 or 2 months, then you will end up like on the first photography of the spaghetti. Let's go to the other slides. And you will end, when we are talking about spaghetti, we can as well replace it with a big bowl of mud. So you can imagine this mud that you are getting in, and then it's very hard to get out. So this is exactly what I told. If you get in this mud is probably fine if you just step into it and then go out. But if you fall inside, sorry guys. What can be a solution to the modules, the communication between modules? How we can make it loosely coupled? First, we can do the independent modules. And from the independent modules, I mean every module could have a separate data store. So imagine we have this big ball of mud. Everything is connected with everything. And you as a superhero, you get into that project and you have somehow to untighten it, to make it loosely coupled. So what can you do? You can first try to divide the data which you were storing. Because if you had just one database, and within this one database, you stored everything what was related to events, tickets, invoices, orders, etc., there is a high chance that you over-engineered your solution. And why? Imagine that orders need some information about a ticket, a name, and maybe a price. That's it. Tickets needs more information. It needs name, price, the date that it was ordered, the surname and name of the guy who ordered it, maybe the location of the guy who ordered it, or whatever else. And now you have a lot of over-engineered data for the orders. Is it correct? If I, as an order, I need just 2 properties, then why should I use a huge entity that is stored somewhere in a database with, let's say, 50 properties? It's an overkill. And this can be easily done by separate data stores. So this means I will have a data for events, I will have data for tickets, orders, invoices, and complaints. But now you can ask, okay, how they can communicate then? Here comes the solution. And this solution is based on the messaging. Here, you remember this mediator, which we talked about inside one module. Here, it's something maybe similar to this mediator. We have each of our modules, which knows nothing about itself. There is no connection from tickets to events. There is no connection from events to orders, from orders to invoices, or from invoices to complaints. And this particular thing communicates over the central part, which is called message channel. Now, how does it work? Me as a user, I want to create an event. So I am somewhere here, I called my API. My API created the event, and in the end, it sent the message into the message channel that, hey, event A was created. Now, if there is another module for which it is a relevant information, it takes this message, so for example, tickets, and tickets creates a pool of tickets for this event because it got the information to which it was subscribed to the message channel. That's it. Same goes here. A user who is somewhere here makes an order. Order is created. Module orders sends the message to the message channel. And from the message channel, there is an invoices which are subscribed to the, for example, topic. And it takes this message and generates the invoice. And now it's great because this module knows nothing about this module, and this module knows nothing about this module. All in all, it starts to go into the direction of something that is called modular monolith. We started our architecture with monolith. Now we are on the level of modular monolith. So we have modules which are independent. What is wrong, or maybe it's not wrong, but what can be wrong? It, of course, all depends on your situation inside your company, inside your project, if you need to scale or not. But let's say you don't need to scale. Then this solution is perfect because you have a single deployment unit. You have one solution. You are deploying this solution, for example, as an app service. That's it. It works. Great. You solved the world. You rescued the world. That's it. But there might be a situation that you want to scale. And if we go back for a second to this particular drawing, the problem would be that we will have all parts which are here. So events, complaints, invoices, tickets, and orders modules deployed all together. So if you do the change in orders, small tiny change, maybe someone asks you to just replace something in one algorithm with another algorithm, which is like maybe 1-2 days work, and you need to redeploy a whole unit. Events, complaints, invoices, tickets, orders, all together. You need to grab it and you need to deploy it. And that's fine, as I mentioned. If you don't want to scale, that's perfectly fine. If you want to scale, it's okay-ish. Okay-ish. So not perfect, not bad, but every time you want to scale and put a new instance of this application, you will need to just deploy all together. It takes time, it takes money, and in general, it's always better to not to do such things. For solution number 2, we have the independent services. Now, with independent services, we are taking our modules and, hey, you just saw this slide, because it's the same from that perspective. Our services are next step to modules. So instead of calling it module, I can call it service. And I have a service of events with its data store. I have tickets, orders, invoices, complaints, whatever. But our modules just evolved to something new. How does it look from the deployment perspective? From the deployment perspective, we are moving to the strategy that is called microservices. I'm pretty sure, I might be wrong, but I'm pretty sure that you have heard about microservices in the last 2-3 years. At the moment, it's completely overused. It's used everywhere in new projects, everywhere. So like you have 5 microservices in your system and your system is used by 100 users, you use microservices. You have 10,000 users and 25 modules, you use microservices. You have 700 modules and millions of users, you use microservices. Microservice to the rescue. But that's not true. It's not always great solution. It's always good to start from the modular monolith that I showed you, and then, based on your needs, maybe then evolve your system in the direction of microservice. So there are a couple of things that are worth to mention. You can have this modular monolith, and there you can have 10 modules, and then you can see that, these events, or maybe events is a not good, it is a not good example, but tickets. You know how it's usually with the ticket systems. You want to buy a ticket for Champions League, for the final. You open the page, and then this page is not working, not responding for 5 minutes, 2 minutes, 3 minutes, 10 minutes afterwards, all is bought. Yeah, that's one thing. Probably it's just run in most of the systems as a single deployment unit. And now with your modular monolith, if you would have it, you might want to scale just this tiny little module for tickets, and not entire solution, not whole modular monolith. Therefore, you will have here 9 modules inside modular monolith, and 1 module, tickets, will be taken out as a microservice. Yes? Now, you will have 2 deployment units, so multiple ones. One will be modular monolith, second one will be tickets. And as we go forward, for the next step, there is a problem with, in your application, there is a problem with poor performance of generation of the invoices. Because there are a lot of orders, and generating invoices, let's say to PDF, it takes time. It has to be rendered, it has to be generated and returned to the browser. And for that particular part, you might take this piece out. This means in your solution of modular monolith, you have 8 modules, and now you have 2 microservices. So you are scaling on demand. You are migrating these modules to microservices whenever you need to. So from that perspective, it all can end up in the situation that every single module that was a part in the beginning of modular monolith can become a separate microservice. From the summary perspective, what I would like you to remember, because as I mentioned, at the moment, you won't face it during your work. When I started, I did not think about such things at any time. So I remember the first day when I came to my job. It was some kind of internship. And during this internship, I got some kind of task. Hey, just, there are a couple of web services, and now we just need a client for this web services, just do it. And I was not thinking about tight versus loose coupling. I was thinking about delivering the solution. And what is the easiest way to deliver the solution? It is just to tightly couple your code, always. Because it's the fastest, you feel safe. And from that perspective, I would like to ask you to just not to do that always. Sometimes think about the consequences that it would have to your project. Because, as I mentioned on one of the slides, it can come up with the failure of entire business even, when the maintenance costs are higher than profits. Another thing is to try to separate the data. This is a very broad topic. And this is a very broad topic in its broadest sense, because To correctly store the data, you need first to correctly model your domain. And trust me, modeling domain is one of the toughest things inside programming, and so maybe not programming, but software development in its general. You need to select correct contexts. You need to think strategically. You need to think tactically about all these things. And this is very, very hard to do that. But in the end, after some time, it will bring a lot of benefits. What is the problem here with this bringing of the benefits in future? The problem is that business usually does not see it. Because if you prevent it, you will not have a problem in future. So, how will you convince your business to prevent it? Usually, it's all about reactions. Something is wrong, let's react. Something is fine, let's leave it as it is. So that's the hardest thing there. And the last point here is all in all about the asynchronous communication. If you can, because you can't always do that, but if you can, just try to make your calls asynchronous. And asynchronous, I mean, like you saw on this message queue. We are sending a message, the request is done, that's it. But the other service is reading it and processing it. But the request from the first call, it's done. After creation of the event, thank you very much, it's created. I don't care what is happening inside our system afterwards. So this means that if you would have a tight coupling between the event creation and tickets creation, imagine your client. Client will make a request to the creation of the event. It creates the event. This client waits for the response, yes? Now, after this event is created, I am trying to create pool of tickets. The client is still waiting. Then after it's created and it's stored, the response goes back. Quite some time. If you do that asynchronously, then, for example, you do this creation of the event is done, it sends the message that the event was done, it returns the response to the client, hey, done, and the client does not need to wait until the tickets are created, this pool of tickets, it's done under the hood. And why I say it's not always possible to do that asynchronous things, because sometimes there are requirements that something has to work immediately. With asynchronous calls, like with this messaging part which you have here, it's quite hard because you have no control over the flow. With synchronous one, you have a control, so you send the request response done, that's it. And sometimes there are such requirements that it has to be immediately available. All the information that you created has to be immediately available. Then there are different strategies that you can apply. But as I mentioned, it's not always possible to go such an asynchronous way. However, keep it in your mind when you think about it. Just think, hey, maybe it would make sense to do that. Because why we want to lose our resources just by waiting for the synchronous ones? And from my perspective, that's it. Thank you very much for attending this session. And I ask you for questions. Do you have any? And yes, there was a question.
Yeah, so my question was about like error handling. How would you do that in this asynchronous, like the ticketing system fails? How would you roll back stuff in the event creation process?
there won't be there will be a situation about an error, of course, but there won't be a situation if I decide for making it asynchronous here. When I create a ticket, and ticket is created, when I create an event, and event is created, that's it. I don't care what is going on behind the hood. I don't care. But there is a chance, as you mentioned, that tickets will fail. The creation of the pool of the tickets. And here, there are a lot of different strategies as well to handle this error handling. What you can do is that anything that failed goes back for processing. Let's say you have another queue. Let's call it queue. And then the error goes back. Because there might be a situation that the service was unavailable. Yes, for tickets. It could be unavailable. So you can make it like 3-time loop. You can make it with circuit breaker that you just send the request, it failed, went back. Then you try after 1 minute again. If it is again broken, then you cut it out and don't care about it. And then there is, for example, during the night, there is a task, asynchronous one. You can do it via multiple ways, for example, using Hangfire. Hangfire grabs all the failed ones and tries to do again the processing of the pool of the tickets, yes? There might be as well a situation that me as a programmer or me as a business, I have a requirement that after it fails on the ticket creation, I immediately roll back everything. So it's not a rollback because this is not anymore a transaction. I committed it into the database with the event creation. But I can drop it or archive it and make it like failed status. And that's it. And try to recreate it even immediately. Or
the event service know about the ticket pool creation failing. So would that be another asynchronous message or what?
The question is if event service cares about it. Because event service does not need to care about it. It's kind of useless, yes, but might be then, as I mentioned, so there might be an information which is sent to some kind of a queue, let's call it failure queue, from the tickets. And from the tickets perspective, it gets back and it triggers then, for example, sends the message, hey, ticket creation failed. Me as an event service, I am taking this information and I am dropping the event, informing the user that there was an error. But there are so many different ways of handling it. That's usually up to the business, what is the decision? Because this is the requirement from the business, how to handle it. Business wants to make their users happy with the usage of the application. And we can handle it in many different ways. It's all based always on the business requirements. Are there any other questions? There is a members module, and this members module receives the information about the registration of the user. This user is registered, and after he is registered, there is a message sent with, for example, full information from to this message queue from the registration form. Now, me as a tickets module, I take this message. But I take from this message, let's say this is a JSON, then I take 2 fields, that's it. Because I am interested only in 2 fields. But in the meantime, events took as well this information about this message and took 5 fields out of the 50 that was sent by registration form. That's it. Very important thing is that this message queue, which is in the middle, so this central part, that it is very stupid. So it does not do these things. It just receives message and informs others about the messages. That's it. That's it. So you registered to the system, so you are a user. But for other module, you are a member. So, and as a member, I want only to know your name and surname. That's it. by the user, I want to know as well email, I want to know maybe your date of birth, and whatever else. I am interested in many other things. So that's why it's very important to find this correct context when you are modeling the software. And then, based on that, create a map which you can use between the user and the member based on your example. Yeah. Data duplication, you are right, there will be the data duplication, but to be honest, I don't care. This is as well this question which you mentioned about consistency. You can say there will be eventual consistency. So whenever I am registering a user, yes, I am sending the information somewhere or creating the event. I am sending the information somewhere. I expect that this pool of tickets will be created for the event. If it's not, sorry. Or if I am missing some kind of the information there, I take it and I make some kind of a decision if this is very important thing, very important information, or I can live without it. Because sometimes there are situations that you don't care about this data. Then the question would be, okay, why to model it? Why to store it even if we don't care about it? And that's another question which can raise questions again to the business. And this is very complex topic about this things of consistency, eventual consistencies, and all the things around. Another question.
How do you handle breaking changes of, for example, one microservice? So when you change the interface from JSON to XML?
Usually, I will answer that. Usually you don't change it like you do not change a database provider. In theory, it's possible, of course, but in majority of projects, you don't do that. However, when you talk about extension, so let's say I have a contract, yes, and this contract has 12 different fields. And now I did a change in one of the microservices, let's say events. And I don't use anymore 2, and I added 3 fields. Yes? Crazy thing. I had 12, now -2 plus 3, phew, mathematics. And what I do, or maybe what you can do, is to stay with the contract as it was. Additionally, you added these 3 fields. So you did not remove from the contract because it might be a breaking change for any other part in the system. So you leave these ones which you dropped, you add new ones, and there will be no breaking change because any of this module, none of these modules will be interested in this data because they don't know it yet. So now you are safe from the perspective of the removal of the data from the contract because all others, if they subscribe and they need this data for something, then they will have it still on a contract side, so contracts will not be broken, but there will be extension of the 3 new fields, and they can then implement it in a half year or in a 1 year if they need this information. They can take and, hey, I need it. So that's it.